Hello and welcome to my YouTube channel. If you have subscribed already, please, when you are watching the video, at least try to like the video for me. It will not be fair that you watch the full video, come on, like you don't want to give it to me. Thank you for doing that. Okay, good. Now we are going to look at the horizontal motion involving constant retardation or negative acceleration. In fact, I've already explained this concept to you. You know, when you say something is retarding, that is when the acceleration is negative. It's not the same as when the velocity is negative. When acceleration is negative, it means that that particular particle is slowing down. Is that okay? It's slowing down, or the speed is what? Going down or slowing down. Let me use that one. Then, when it comes to negative as velocity, means that it's moving opposite to the other particle. So there are different things here. Now, for this one too is also involving in constant retardation and horizontal motion. And for this, what happened here is that the formulas that we use for acceleration is the same thing here. So we have a formula that says that V is equals to U plus 80. Now you are saying that for retardation, acceleration is always what? Negative. Is that okay? So it means that my V is going to be U minus what? 80. If I replace this A by this, then you also have V squared equals to 2A, I forgot to know, U square, right, plus 2AS. So if the acceleration is negative, I have V square will be U square minus 2AS, equation 2. You see that they are the same. It's only the signs that are changing. You also have V squared, sorry, we have S is equals to half U plus T, U plus V times T. Here nothing will happen because there's no acceleration there. So I think this one self is not needed. So let's save this one, leave, go to S equals UT plus half AT squared. So now if I replace the acceleration by the negative, I have S equals UT minus half AT squared. Now you see what I've done here. In questions, normally, so this is equation 3. In question, normally, this is what happened. A lot of people, let me emphasize on this. When a question is given, and in the question, it is already given in the negative acceleration. That means if you want to use this formula, then you have to change it to positive so that it will fit with the formula. So when the question is given and it's negative, then if you want to use, then you come to this formula. But if it is positive, but they say it's decelerating, then you use this one. The positive number, when you bring it here, nothing will happen. Understand what I'm trying to say? Okay, we will solve an example and see what I'm trying to say. First, let's look at our example 1. A Metro Mass bus driver applies the brakes of the bus as he approaches the main station to produce a steady deceleration of 0.04 meter per second squared. Now, here the question has make it clear that it is what deceleration, okay? In some questions, it will not be mentioned that it is deceleration, but you will see that the acceleration is negated. I hope you understand what I'm saying. Good. And brings the bus, there must be, and bring the bus to rest at the main station in 1 minute 10 seconds. Okay. Now, to bring the bus to rest, you see that will be the final velocity. So at the final side, the bus goes to rest. So the final velocity becomes 0. Okay. Find the speed of the bus in kilometers per hour at the moment when the brakes were applied. So you need what? Initial velocity. Immediately the driver step his foot on the brake. At that time, the bus started moving. So that is the initial velocity we are looking for. So first thing, then we need it in kilometers per hour. So It will be better for you to work in meters per second. After that, you convert it to kilometers per hour. Or you convert everything here, this one to kilometers per hour, and this time 2 to per hours, okay? But let's convert everything to meters per second after we convert to kilometers per hour. So the first thing here, let's get our information. Our V is 0 meters per second. Our initial, we don't know, okay? Our acceleration is giving us, now look, our acceleration, or furthermore deceleration. So our deceleration is given as 0.04 meters per second square. This is deceleration. I'm maintaining this, but it is deceleration. Let's maintain that. At rest, okay, that one. 1 minute 10 seconds. 1 minute, not minutes. 1 minute 10 seconds. So what it means is that in our time will be, so you convert 1 minute 10 seconds to seconds, that will be 70 seconds. Okay, 70 seconds. 70 seconds. Okay. Now, you know that if I use this, V equals U plus 80, I'll get it, right? But because we are talking about deceleration, the formula here becomes what? Negative. Is that okay? But if you maintain your plus here, then you should negate this because it's deceleration. Okay. So I want to use this one. So final velocity is 0. We need, in fact, we need the initial. Immediately the driver apply the brake, so we need the U. A is 0.04 times what? 70. So my U will be equals to 0.04 times 70. Let me use a calculator. This gives you 2.8 meters per second. But if you want to convert this 2.8 meters per second to kilometers per hour, so my U will be 2.8 meters to kilometers. You know, you divide it by what? 1,000, right? Divided by, look, this per, so the seconds to is like this. Seconds to hours is what? 3,600. Is that okay? So this will give you U equals 28, or you stand and move 1, 2, 3, 2800 times, please, this one is dividing, so it will go here 1, 2, 3, right? So that will give you U equals 0.0028 times 3600. So my U is going to be kilometers per, sorry, 10.08 kilometers per what? Ah, is that okay? So this is what you are going to get. Thank you. Now let's move to the next one. The distance then traveled before stopping. So the B, you want the distance, okay? But you know, you can use this one. V squared equals U squared plus 2AS, right? My V is 0, so 0 squared equals, now because this is deceleration, I'll bring minus. My U squared, that's what we work. We had 2.8 meters per second before you change it to kilometers per hour. My U squared will be 2.8 squared minus 2. Acceleration is 0.04 times s. So I need distance. So if I do everything, my distance will be 8 meters. Okay. If you make s the subject from this, you get 98 meters. Very good. Now let's look at last example. Okay, now let's look at this example 2. A train is brought to rest from a from a velocity of 24 meters per second with a constant acceleration of negative 0.8 meters per second squared. So this tells you that it's decelerating. If you are using the negative, the formula, you don't bring negative again, you maintain the plus. But if you are sending the positive only, then you bring negative in the formula. Okay, draw a velocity time graph and find the distance covered by the train while it is decelerating. Good. So first, let's look at our U. A train is brought to rest. Is brought to rest from a velocity of 24 meters per second. So it was coming from somewhere which was 24 meters per second. So that means the initial is 24 meters per second. And final will be what, 0 meter per second, because it brought to rest means that at rest there is no velocity, there is no movement, it stands still. Okay, with a constant acceleration of negative 0.8, so my acceleration is negative 0.8 meters per second squared. So this is what we have for the acceleration. So we should draw a velocity time graph and find the distance covered by the train whilst it is decelerating. Now look at what is happening. In fact, when a question like this is given, one thing about the questions like this is that if you want to use the velocity time graph to solve, because you have been directed, you see all what I've been solving, I don't use the velocity time graph, but you can use it. So they say I should use it. So I've been directed to use the velocity time graph. So what I'm going to do here is that before you can use velocity time graph, as the name goes, velocity time. So you need to get the time. So let's work here. V equals U plus 80. You see I'm using plus here because already the negative I have it here already. So my V is 0. My U is what? Is 24 minus A is 0.8 times T. I want to find T. So if I group like terms, I'm going to have 0.8 T equals 24. But this 0.8 can be written as 8 over what? 10, right? Which is the same as 4 over 5T is equals to 24. So this will be T equals 24 times 5 over 4. 4 goes here, 1 go into 24. 6 times 6, 5 is 30 seconds. So our time will be what? 30 seconds. So let me clean this once. I just needed the time, okay? That's why I wait for it. But the question is asking us to use the velocity time graph. So this is my V, this is my time. We have 24 meters per second, okay? So the velocity is in terms of meters per second. My time is in terms of seconds. So now, this will be the initial velocity. So the train was actually here, and the train decelerates to this place, which is what? 24 seconds. Is that okay? Hey, is it 24? 30 seconds. 30 seconds. Is that okay? So now we have to find the distance covered by the train whilst it is decelerating. And I've already informed you that when you say a distance, is the area under the shape available there. What shape is this? This is what? A triangle. And what's the formula for finding the triangle? Is half times base times height, right? So S equals to half times base, which is 30, times height, which is 24. So my this will be half of 30 is 15 times 24. This will give you 360 meters. Is that okay? 360 meters. And this is very simple to do. So you see, we can work it under what? A diagram like this. if there was no diagram given, or if they did not direct you to use velocity time graph, you could have just go straight by saying that, let's say v squared is equals to u squared plus 2as. Then you substitute the values here. You see that you will get the same answer as the 360 here. Is that okay? Thank you very much for watching. Let's move to vertical motion. Okay, as we have horizontal motion, you can also have vertical what motion. That's where gravitational force come to play.